the external setup of Hall effect. Now I will explain first construction of this setup. This is the Hall probe. See, here is a thin semiconductor plate is attached here. 4 wires are drawn from these semiconductor plates. And this Hall probe is to be kept here. This is the electromagnet. This, by rotating this, the distance between North Pole and South Pole can be adjusted here. This is the Gauss meter probe, by which magnetic field at the center of the pole can be measured by this probe. This is the power supply for this electromagnet. This is the Hall effect setup, by which the Hall voltage and Hall current can be measured. And this is the digital Gauss meter, by which magnetic field at the center of the pole, by the use of this probe, magnetic field can be measured by this instrument. This is the construction of the setup. Now this is power supply. This is plus terminal, minus terminal. These two wires go to the for electromagnet C. This red terminal connect to the red terminal and black to black here. This is the coil winding here. Due to if current passed through the wire, the magnetic field is produced here. Now see, this is the Hall probe having these 4 wires. This is the red terminal is here wire, it's to be connected here. This is the black wire is to be connected to the black terminal. This is the yellow wire to be connected to the yellow terminal. This is the green wire is to be connected to the green terminal. And see, this is the adjustment. Hall current can be adjusted by this knob. For low current, for high current, you can select this switch. Current can be measured here. This is the current and this is the voltage. That means we have to measure the Hall current and Hall voltage by the use of these two knobs. Here 0 setting knob is provided here. See here, this is the current meter range. By the use of this range, we can measure the Hall current. And if you put this knob here or here, voltage, Hall voltage can be measured by the same instrument. And see, here are two indicators, milliampere and millivolt. Accordingly, if this indicator close, you can measure the milliampere Hall current in milliampere. If this indicator close, you have to measure the Hall voltage in millivolt. Now see, this is the probe. This is the Gauss probe. You have to use this probe here to measure the magnetic field. You have to put here this probe at the center of the two poles, and here we can measure the magnetic field here in the Gauss. We can adjust the range by the use of this knob, and this 0 adjustment knob is there here. This is the whole construction. Now we shall see the working of the Hall effect setup. See, if Hall probe is connected here and Gauss probe is also connected here. See, and distance between these poles is I have kept 2 centimeter. And now I am starting this. All the equipment I have made on. Now initially we have to Gauss probe, we have to take the outside of the electromagnet, and we have to adjust this 0 for 0, initial 0. This is current is 0. You have to adjust this current. If initial current is there, you can adjust 0 here. And we have to put the current initially 0.25 ampere. And this current is passed to the electromagnet. Now I am putting this Hall probe and Gauss probe in the gap of the 2 poles, South Pole and North Pole here. See. Yes. Now see. The magnetic field is 0.36 Gauss, and here see, Hall voltage is 10 millivolt, and in order to measure the hall current, you have to put the switch here for milliampere range. See, this is the milliampere indicator, and this is the hall current 4.4 milliampere, and this is the current applied is 0.25 ampere. Here we have to repeat the same experiment in the steps of the 0.25 ampere. That means in the next step we have to put the current of 0.5 ampere, and similar process we have to apply and measure hall voltage and hall current and magnetic field. And by the use of these links you can calculate the hall coefficient. Okay, thank you.
परफेक्ट इलेक्ट्रॉनिक्स वाई आयोजित 6 दिवसांचं प्रॅक्टिकल बेस्ड इलेक्ट्रॉनिक्स अँड कम्प्युटर इंडस्ट्रियल ट्रेनिंग.
पात्रता इलेक्ट्रॉनिक्स आणि कम्प्युटरचे शिक्षण आवश्यक. बीई, डिप्लोमा, बीएससी, एमएससी झालेल्यांसाठी उपयुक्त.
या ट्रेनिंगमध्ये भरपूर प्रॅक्टिकल सह मुलाखतीची तयारी करून घेतली जाते, ज्यामुळे जॉब मिळणं सोपं जातं.
ट्रेनिंगसाठी संपर्क डॉक्टर ढेकळे, परफेक्ट इलेक्ट्रॉनिक्स MIDC वाई. मोबाईल 98 222 41 255.